What's up, everybody? Ramon Torres, the educator at School Your Brain, and I'm going to show you how to use inverse operations the correct way. So I'm going to show you two examples which gets a little bit of confusion. So when should you divide versus when to subtract or add or multiply. So let's look at a couple examples and hopefully it'll help you out. Let's do 3x is equal to 6. So I'm going to represent that with a visual model. So it's like a scale balance. And a scale balance, that's pretty much what equations are. We're starting off with two amounts that are equal to each other, so they're balanced. So think of like a seesaw. If you have the equal weights on both sides, it's going to be exactly the same. So we assume the equation starts off balanced out. And what we're going to do when we solve it is that, like, if I do something to one side, it might make it'll make it unbalanced. So basically, to keep it balanced, you always want to make sure the same thing happens to both sides. So I'm going to show you pretty much what's going to go on with this problem, and we'll go back and forth with this idea of the scale balance. So here we have 3x equal to 6. So I'm going to represent that on the scale. So 3x, I'm going to circle that here. That's my 3x. And on the other side, I have positive 6. So I'm going to draw 1, 2, 3, 4, 5, 6 positives on this side. And now the goal when solving an equation is you want to figure out what's the value of 1x. So just 1. So what I want to do now is I'm just going to draw my scale balance, and don't mind my art here. What we're going to do is we're going to, again, represent 1x. We want 1x. So what I'm going to do is I'm going to split up this 3x into 3 different groups. 1, 2, 3. And you can see that in each group there's only 1x, and that's what we want. I don't want 3 x's together. I want them separated. So I split them up into 3 groups. And now on the other side, we had those 6 plus signs, right? 6 positives. So your job now is to figure out, okay, how can I group these 6 plus signs into 3 groups? Because I want to match it up. And the way I would do that, I can see here that I can group 2 per group. So if I put 2 in each group, you can see here that we can figure out what is the value of one of those x's, because, and I'm going to draw one more. For each x, I can see that matches up with a group of positives. And that is the answer for this equation. And if I were to go back now to the actual equation here, without in the symbolic form, so 3x equals 6. When I split it up into 3 groups, you got to ask yourself, what operation is that? When you take an amount and you split it up into 3 groups evenly, is it add, subtract, multiply, or divide? In this case, when we split things up into groups, or split it up into equal groups, that is called division. So what I'm going to do is I'm going to model that here. We divided it into 3 groups, both sides. So here I'm going to divide both sides by 3. And you can see in the very last step that we ended up getting 1x matches up with 2 positives. And I can see that for every 1x, we get 2 positives that matches up. And that's what we call simplifying. We divided both sides by 3, and we can see that in each group, you get 1x matches up with 2 positives, or 2. So that was division. And notice that one thing to point out, that we talked about the scale balance. So by splitting things up into groups, you're not affecting the balance, because all you're doing is dividing them up. So you still have the same amounts on both sides. It's just that you're able to identify how much is in each group. Now let's look at something else, like x plus 3 equal to 6. Now I want to model this again using my scale balance, the idea of a scale balance. Again, we're assuming it's already balanced. So I'm going to draw my x, and I have 3 positives, right, plus 3, so I'm going to represent it as 3 positives. And then 6 positives on the other side, so 1, 2, 3, 4, 5, 6. And what I'm going to do now, let me actually copy this here, because what I'm going to do now is say, okay, my goal, again, same goal, I want to figure out what is the value of 1x. And the way we can do this is by eliminating things, because nothing is grouped with the x. The x is already isolated, technically. We just got to get rid of those plus signs that are on the same side. We want the x to be by itself on that scale balance, on the left side of the scale balance. So what I can do is I'm going to start eliminating the pluses. So see, I'm going to erase 1, So I got rid of 1. And remember, if I take away 1 from one side, if I were to just stop there, that side that I took away from is going to be lighter. And now it's not going to be balanced anymore. So you got to ask yourself, how do I keep it balanced? Well, what do I do on the other side? If I took away 1 from one on the other side, what do I do to the other side? Well, I got to do the same thing. I'm going to take away 1. But you can see we're still not done yet. So I'm going to repeat the process. Then I'll take away 1 more. And if I take away 1 from one side, to keep it balanced, I'm going to take away 1 from the other side. And then again, if I take away 1 from this side, I got to take away 1 from the other side. And now you can see that we're left with 1x is balanced with 3 1s. So as long as I keep doing the same thing to both sides, the balance stays the same all the time. But if you only do it to one side, if you forget to do it to the other side, you're going to lose that balance. So it's very important that you do the same thing. So if anytime you take away something from one side, do it to the other side as well so it stays balanced. And now I'm just going to represent that over here in my equation. What do? We ended up taking away 3 pluses from one side and 3 pluses from the other side. So in other words, I took away 3 from the left side, and I also took away 3 from the right side. Again, that is going to keep the equation balanced. By doing the same thing to both sides, it stays balanced. And then after we took away 3 from each side, what was left? Well, I was left with an x on one side and 3 on the other side. And that would be my final answer. So let's do this one now. X minus 3 equals 4. So I'll draw my scale balance again. I'm going to represent it. I have an x. Now, x minus 3, I'm going to consider those. If I ignore that x sign, or actually if I rewrite it, let me rewrite it into addition format. X plus negative 3 equals 4. That might make it a little bit easier. Taking away 3 is the same thing as adding negative 3. So I'm going to represent the 3 as negatives. So I have 1, 2, 3 negatives. And on the other side, I have 1, 2, 3, 4 positives. And now, don't forget the goal is always to get 1x. What is the value of 1x? And I'm going to show you a little side note. There's something called a zero pair, which is a very important thing to keep in mind when you're solving equations. Zero pairs are useful because they help you solve equations. So a zero pair is simply this. When you combine a positive and a negative together, that pair comes out to be 0. That's why we call it a zero pair. So opposites cancel each other out. And we can use that to solve equations. And you can see here that we have 3 negatives on the left side. Let me just do a quick copy of this. So I have a copy of that. Okay, so this is my copy. So I just did a little copy so I can have another example underneath. So going back to the idea of a zero pair. If I introduce a positive and a negative together, they're going to cancel each other out. They disappear. They're gone. It's 0. So I'm going to use that. So on the left side, I have 3 negatives. So I'm going to end up putting 1 positive here. That creates a zero pair there. So I know when I combine those two, they're going to be gone. But remember, we want things balanced. So if I put a positive on one side, it's not balanced anymore. I got to add the same thing to the other side. So I'm going to add a positive on this side. And then similarly, I'm going to repeat the process. So for this one, I'm going to add another positive to that one. If I do it to one side, I'll do it to the other side to keep it balanced. And then the last one, I'm going to make another zero pair here by adding a positive. And remember, if I do it to one side, do the same thing to the other side. And now, let me copy it one more time. Let me just draw another copy of this so I can simplify it in the next step. Okay, so now remember, we ended up, so let me actually add that stuff over here. So we ended up adding 3 on one side and 3 on the other. So we introduced 3 positive on the left side, 3 positives on the right side. Now we're going to simplify. So if you look at this step down here, we get those things we call zero pairs. Positives and negatives combined, they disappear. They come out to be 0. So look, that we get rid of 1, 2, 3 zero pairs are gone. And we isolated x. We have 1x by itself. And on the right side, there are no zero pairs. There's all positives. And you can see we ended up with 7 positives on the right side. So when I simplified both sides, we were left with x on one side and 7 positives on the right side. And now we know the value of x. Okay, here is our last example. So I'm going to model this last one. So x divided by 3 equals 2. Keep in mind, it helps to know that x over 3 is the same thing as 1x over 3, which is also the same as 1/3 x. Those are all equivalent. They're the same exact thing. I like to look at it in the format as 1/3 x because remember, x is the whole amount. We want to know what is the value of 1. Here we have 1/3. It's not the full amount. It's a small amount. So what I'm going to do here is I'm going to represent it as a bar. And we have 1/3, which means we don't have the whole amount. We only have 1 out of those 3 pieces. And on the other side, we have 2 positives. So let me draw 2 pluses to represent my +2 or my +2. Remember, we want the whole amount, not 1 out of the 3 parts. We want the whole thing. This is one of my favorite problems because, it's very visual. You can see what's happening. I love the fact that you can see what's going to happen here. So check this out. We have the shaded part. 1 out of 3 is shaded. That's what we mean by 1/3 of the whole amount. And I know that one of those parts already that we have shaded, it balances with 2. So check this out. If I were to shade one more section, then I know on the other side, I would have to add 2 more positives because we already knew originally 1 out of those 3 pieces balances with 2 positives. Therefore, for every one part, 1 out of those 3 is going to keep balancing with 2. So I have 2 of them shaded out of 3, so that means I have to add another 2. And then the last part, if I do it one more time, right, if I shade another piece, that means I have to add another 2 on the other side for it to balance. So that very first part is critical because we knew that 1 out of 3 sections balances with 2. So for every 1/3 that I keep adding into it, is going to keep balancing with 2 on the other side. And the key part here now to ask yourself is, what operation did we use when we went from 1 to 3 parts? So some of you may be thinking we added 1 out of 3 plus another 1 out of 3 plus another 1 out of 3. But I don't know if you know, but the shortcut for repeated addition is multiplication. In other words, we started with 1 part out of 3 and I tripled it. I times it by 3. So I'm going to show that work over here. I tripled that side. And now look at the right side. We have triple the amount. We started with 2. Now we ended up with 6. So we also tripled the other side as well. And 3 of those 1/3 pieces, 3 of those together, makes up 1 whole amount of x. So 1x. And 1x, or the whole amount, is equal to 6. But normally we don't write the 1x, we just put down x. They're the same thing. So x is equal to 6. So this is just a little introduction to solving equations with models, so you can kind of see what's really happening when you use inverse operations. In other words, when you add, subtract, multiply, or divide the same amounts to both sides. If you like this video, like, subscribe, and leave a comment as to what I should do next.